Introduction. Brief history of electric and self-driving cars. The history of electric cars dates back to the late 19th century, with the first electric car being built in 1884. However, the technology did not gain widespread popularity due to limitations in battery technology and the availability of cheap gasoline. In the early 2000s, a renewed interest in electric cars emerged due to concerns about fossil fuel emissions and climate change. This led to the development of more advanced batteries and the introduction of hybrid and fully electric cars by major automakers. Self-driving cars, also known as autonomous vehicles, have a more recent history. The concept of a self-driving car can be traced back to the 1950s with the advent of radar and computer technology, but it wasn't until the 21st century that significant progress was made in the development of autonomous vehicles. The Defense Advanced Research Projects Agency (DARPA) Grand Challenge in the early 2000s, a competition for autonomous vehicles, helped spur development and research. Since then, many companies and automakers have been investing heavily in the development of self-driving cars. The first self-driving cars were seen on the roads around 2010, and since then the technology has been continually evolving and improving. Electric cars. Advantages of electric cars. Electric cars produce zero emissions and are considered a clean and sustainable form of transportation. They are cheaper to operate than gasoline-powered cars, as electricity is cheaper than gasoline. Electric cars are typically quieter and have instant torque, providing a smooth driving experience. Electric cars have a smaller environmental impact, as the electricity used to power them can come from renewable sources. Battery technology advancements. Battery technology has been a major hurdle for the widespread adoption of electric cars. However, advances in lithium-ion batteries have led to improvements in energy density, cost, and durability. Battery technology is still an active area of research and development, with new technologies such as solid-state batteries being developed to improve upon the existing lithium-ion batteries. Charging infrastructure. The lack of charging infrastructure has been a barrier for the widespread adoption of electric cars. However, governments and private companies have been investing in the development of charging stations and networks, making charging more convenient and accessible. Fast charging technology is also being developed to reduce the charging time for electric cars. Government incentives and regulations. Governments around the world have been implementing policies and incentives to encourage the adoption of electric cars. These can include tax credits, grants, and subsidies for the purchase of electric cars, as well as regulations requiring a certain percentage of new car sales to be electric cars. Government regulations have also been implemented to reduce emissions from gasoline-powered cars, which further encourage the adoption of electric cars. Current market trends and projections. Electric cars have been gaining market share, with increasing sales in recent years. However, they still represent a small percentage of total car sales globally. Market research suggests that sales of electric cars will continue to grow in the coming years, with some projections suggesting that electric cars will make up a significant portion of new car sales by 2030. Self-driving cars. Overview of autonomous driving technology. Autonomous driving technology, also known as self-driving cars, is a combination of sensors, cameras, lidar, radar, and artificial intelligence that enables a vehicle to drive itself. The technology can be divided into different levels of autonomy, from level 0, no autonomy, to level 5, full autonomy. Advancements in technology such as machine learning and computer vision have been key to the development of autonomous driving systems. Sensor technology and mapping. Autonomous cars rely on a variety of sensors such as cameras, lidar, radar, and ultrasonic sensors to gather information about the vehicle's surroundings. High-definition maps, which provide detailed information about the environment, are also used to assist autonomous cars in navigation. Sensor fusion, which combines data from multiple sensors, is also an important aspect of autonomous driving technology. Levels of autonomy. Autonomous cars can be divided into different levels of autonomy, based on the level of human intervention required. Level 0. No autonomy. The driver is in complete control of the car. Level 1. Assisted driving. The car can assist the driver with certain tasks such as braking or steering. Level 2. Partial autonomy. The car can control certain functions such as acceleration and steering, but the driver must remain engaged. Level 3. Conditional autonomy, the car can drive itself in certain conditions, but the driver must be ready to take over if necessary. Level 4. High autonomy, the car can drive itself in most conditions but may still require a driver in certain scenarios. Level 5. Full autonomy, the car can drive itself in all conditions and no human intervention is required. Safety and regulatory concerns. Safety is a major concern with autonomous cars, as the technology is still in its early stages and accidents impact on the automobile industry. Disruption of traditional car manufacturing. The development of autonomous cars is likely to have a significant impact on the automobile industry, as it has the potential to disrupt traditional car manufacturing. Self-driving cars are likely to be electric cars, which will further change the traditional manufacturing process. With the advent of autonomous cars, car manufacturers will have to adapt and invest in new technologies, such as sensors and artificial intelligence, to stay competitive. Changes in the way cars are used and owned. Autonomous cars could change the way cars are used and owned, as they have the potential to reduce the need for personal car ownership. Self-driving cars could be used for ride-sharing services, which could reduce the number of cars on the road and lead to more efficient use of vehicles. Autonomous cars could also change the way people use cars, as they would be able to use their travel time for other activities. Potential for new business models. Autonomous cars could also lead to the emergence of new business models, such as pay-per-use or subscription models for car usage. With the advent of autonomous cars, new opportunities could arise for companies to provide services such as autonomous car rental, fleet management, and car sharing. Impact on jobs and employment. The development of autonomous cars could lead to significant job losses in the automobile industry, particularly in areas such as manufacturing, driving, and maintenance. However, the development of autonomous cars could also lead to the creation of new jobs, particularly in areas such as software development, data analysis, and sensor technology. The impact on jobs and employment. Impact on transportation. Changes in traffic and congestion. Autonomous cars have the potential to change traffic and congestion in cities, as they have the ability to communicate with each other, optimize routes, and reduce the number of cars on the road. With the help of autonomous cars, traffic could be reduced, journey times could be shortened, and the number of accidents could be reduced. However, the increased use of autonomous cars could also lead to an increase in congestion in certain areas if not properly managed. B. Potential for increased efficiency and safety. Autonomous cars have the potential to increase efficiency and safety on the roads by reducing human error, which is a major cause of accidents. Autonomous cars have the ability to optimize routes, improve traffic flow, and reduce the need for traffic lights and signs, which could increase efficiency. Autonomous cars also have the ability to adapt to changing road conditions, such as construction or accidents, which could increase safety. C. Impact on urban planning and infrastructure. Autonomous cars have the potential to change urban planning and infrastructure, as they could reduce the need for parking spaces and lead to more compact, walkable cities. Autonomous cars could also lead to changes in the design of roads, as they would be able to handle higher speeds and tighter turns. Autonomous cars could also lead to changes in transportation infrastructure, such as the development of dedicated lanes for autonomous cars. D. Potential for reducing carbon emissions. Autonomous cars have the potential to reduce carbon emissions, as they could reduce the need for cars on the road and improve the efficiency of transportation. Autonomous cars could also lead to the development of more sustainable transportation systems, such as electric cars and car sharing programs. However, it is important to note that the reduction in carbon emissions will depend on the source of energy for charging these cars, which, if not sustainable, could offset the reduction in emissions. Future of electric and self-driving cars. Predictions for the future of the technology. The future of electric and self-driving cars is rapidly evolving, and predictions for the technology are constantly changing. However, many experts believe that autonomous cars will be widely adopted in the next decade, with some predictions that all new cars will be autonomous by 2040. Electric cars are also expected to gain widespread adoption, with predictions of all new cars being electric by 2035 in some countries. B. Opportunities and challenges. The development of electric and self-driving cars presents many opportunities, such as reducing emissions, improving safety, and increasing efficiency. However, the technology also presents many challenges, such as the high cost of development, the need for infrastructure, and concerns about cybersecurity. The integration of electric and self-driving technology also presents a number of challenges, such as the need for new regulations, the development of new infrastructure, and the need for new business models. C. Investment in research and development. Investment in research and development of electric and self-driving cars is increasing, with many car manufacturers and technology companies investing in the technology. Governments are also investing in research and development, with many countries offering incentives and funding for the development of electric and self-driving cars. Private investment funds, venture capitals, and angel investors are also increasing their investment in the industry, especially in new startups that offer innovative solutions for the technology. D. Government policies and regulations. Governments play a crucial role in the development of electric and self-driving cars, as they are responsible for creating policies and regulations that will shape the industry. Governments are responsible for creating regulations that will ensure the safety and security of autonomous cars. Governments are also responsible for creating incentives for the development of electric and self-driving cars, such as tax breaks, subsidies, and funding for research and development. Government's policies and regulations also play a crucial role in the development of charging and refueling infrastructure, which is key to the success of electric cars.